Let's learn how to easily keep a spare copy of our PostgreSQL databases for our Kamal deployed apps to use in case of an emergency. One of the downsides of using Kamal for deploying your web applications compared to using a platform as a service like Heroku is that you're now fully responsible for the safety of your application's data. That means you'll need to set up processes that'll help you get back up and running without data loss if something were to happen to your running database. And believe me, disaster can strike at any time. In a previous video, I showed how to automate backups for your PostgreSQL databases when using Kamal to deploy your apps. The process shown in that video is for taking snapshots of your running database and storing the data dump to an Amazon S3 bucket. In this video, I'll cover another method of keeping a copy of your data. When setting up PostgreSQL's replication functionality, you can have your main database server automatically copy all its data to another server in real time, ensuring that you'll have all your data in separate servers. Since PostgreSQL is one of the most widely used databases, it's important to know your options so you can make more informed decisions about backups and restoration for your disaster recovery plan. You do have one, don't you? If you don't, then this is a good starting point. Let's see how we can get replication working in a Kamal deployment. For this video, I'll use a Ruby on Rails app I built called TeamYap, which is an app to complement a book I wrote called End-to-End Testing with Test Cafe. I covered this application in a previous video when teaching how to create a Docker file from scratch for Kamal deployments. I'm now using that Docker file to deploy this app using Kamal 2.3. The configuration I set up for my deployments is a fairly typical one for a Rails application. I have a server that's running the web application process and the worker process, and I have all my configuration settings here. Scrolling down, I have a couple of accessories set up for the application. I have a database accessory, which runs PostgreSQL, and I have Redis for my worker process. I set up PostgreSQL on a separate server to keep it apart from my primary web server to make it easier for me to manage. I wanted to look into setting up a replica database to have a standby server in case something goes wrong with the existing database I have running. I can manage the database replication process in this existing Kamal configuration, so let's go through it step by step. The first thing I need to do is set up a new database role or user in my primary PostgreSQL database to allow my replica database to connect to it. The role will be set up as a replication role, which at a high level is a special type of role that can manage replication slots, allowing PostgreSQL to handle how it copies data between replica databases. Because the replication role is considered a highly privileged role since it has access to your entire database, I'll set up the role details as Kamal secrets so I can access them in the container. In the env section of the database accessory, I'll add two new environment variables called replication user and replication password. I'll set up the values for these in my .kamal/secrets file. Once the environment variables are set, I'll go to the terminal and reboot the database instance with Kamal accessory reboot and the name of the accessory, which is db, to place those values in the container. Next, I'll manually log into the container to create the replication role with a SQL query. Ideally, these SQL queries would be executed through an initialization script or some other automated way, but I'm doing them manually for demonstration purposes since this is an already running database. I'll get to the database container shell by running Kamal accessory exec with the reuse flag so it doesn't spin up a separate container, and the I flag to run the command in interactive mode. I'll specify the accessory's name, which is db, and then the command to launch the shell, which is simply bash wrapped in quotes to make sure that Kamal interprets it correctly. In the container shell, I'll run the psql command, which is PostgreSQL's client, and make sure I run it with the primary superuser that the PostgreSQL Docker container sets up through the Postgres user environment variable. I'll use the capital U flag and refer to the superuser with $PostgresUser to grab it from the already set up environment variable. Keep in mind that the flag is a capital U to specify that it's to log in as a specified user, and not a lowercase u since it's an easy mistake to make. I'll also connect to the database that's created in the container by specifying the name, which is set up in the $Postgres_DB environment variable. I don't need to specify a password here since this container sets up trust authentication when accessing the server locally. I'll briefly talk about this later in the video. Next, since I'll want to create the replication role using the environment variables I set up for this, I'll use the C flag, which indicates I want to execute a SQL query. The SQL query can then be specified here in the shell inside double quotes. The query for creating a new role or user starts with create role, followed by the username, which in my case will be the value I set in the replication user environment variable. Then I'll specify that this role is for replication by adding with replication to the query. This part is important to set up replication, so make sure you include it in your query. I also want to allow this new role to log into the primary database server, which I can specify with login. Finally, I'll set up the authentication with password. And inside single quotes, I'll use the replication password environment variable to set it up. I'll wrap up this query with a semicolon and close the double quotes. When I execute this command, we'll get a response of create role from PostgreSQL, which means that the query was successful and the replication role is now set up. So now I have a new role for replication, but I'll need to grant access for my replica database server to connect to the primary database. In PostgreSQL, authentication is managed by a configuration file called pg_hba.conf, usually located at PostgreSQL's data directory in the server's file system. This file controls which IP addresses can access the database server, which users, the authentication method, and more. The Docker PostgreSQL container sets up this file in /var/lib/postgresql/data/pg_hba.conf. So now that I'm still in the container shell, let me output the contents of this file using the cat command. By default, the container sets up various rules, mostly allowing local access to the entire database for all users without the need of a password. These rules are why I was able to execute the create role query earlier by only specifying the superuser account generated by the Docker container when it's initialized for the first time. This file also has one rule towards the very bottom that allows access to any user from any IP address with a password. It uses the scram SHA-256 authentication method, which is how PostgreSQL handles authentication via password. While this rule seems like it would work to allow the replica database to connect with the role I just created, it won't since the connection we'll make from the secondary database server is for replication purposes. If you notice in this file, there are a couple of rules already in place to deal with replication connectivity, but they're all for local connections. I'll use a separate server, so I'll want to create a new rule that will only allow a replication role to connect from that specific server to keep it secure. I'll append the new line to this file through the Linux command line using echo, and in quotes, I'll write the rule that I want to append. The first segment is the type of connection I want to allow. In this case, it's host, indicating that it's a TCP/IP connection instead of a local one. The next segment is the database to allow for connectivity. As I mentioned, this rule is for replication purposes, and PostgreSQL has a special keyword to use here called replication. The replication keyword tells PostgreSQL that this is for a physical replication connection, which is what I'm setting up in this video. Next, I'll have to specify the user I want to allow. Earlier, when I created the new replication role, I set the username with the environment variable replication user, so I'll use that here as well. The next segment in this rule is the IP address and subnet to allow connectivity. Access using replication roles should be as locked down as possible for security purposes, so I'll want to restrict this rule to the replica database server only. I'm using a private network to connect all my servers, so I can use a private network IP address for my replica database server. In the example for this video, the IP address is 10.0.1.3, and I'll use a subnet of 32 to ensure that we're only allowing this IP address. The last segment for this rule is the authentication method. I'll use Scram SHA-256 since it's the most secure password authentication method that PostgreSQL has. After the quotes, I'll append this output using the two right angle brackets to the /var/lib/postgresql/data/pg_hba.conf file. Once I do that, I'll check the contents of the file again using the cat command to make sure that the role is in place with the username for the replication role. One thing I want to point out here is that the changes I made to the pg_hba.conf file are persistent only as long as this container exists. That means if the database container is removed and recreated, this configuration file will be reset to its default. Kamal accessories are typically long-lived containers that won't be deleted and recreated, but there's a possibility that you'll need to recreate the database container from scratch for whatever reason. There are a few ways to make sure that any modifications made to PostgreSQL configuration files are present when recreating a container, like mounting the file in a volume or creating an initialization script. I won't cover how to do that in this video, but please leave a comment or reach out to me if you want to know how to do that. Before moving on to setting the replica database, there's one last thing I need to do with the primary database, and that's to run the database process with a few configuration flags to set it up for replication. The default command that this Docker container runs when spinning up is Postgres. I want to override this command with a few command line flags. In Kamal, we can override the default commands for the accessory using the cmd setting. I'll run the same Postgres command that the container uses, but append a few runtime parameters along with it. The C flag accepts the name of a configuration setting and its value to use, and we can use it multiple times to set different parameters, as I'll show in a bit. Using this flag overrides any settings in the PostgreSQL configuration files if they're set. And while I can modify the configuration file as I did with the pg_hba.conf file earlier, I prefer to set these overrides explicitly in the Kamal configuration so anyone checking how the application is deployed to production knows that the database is set up for replication. The first configuration setting I'll set is wall level with a value of replica. The wall in wall level means write-ahead logging, which PostgreSQL uses to log any and all changes made before they're applied to the data files stored on the server, which can be used for replication and backups. The wall level parameter tells PostgreSQL how much information to write in these logs for different purposes. By setting the value of replica, I'm specifying that these logs are going to be used for replication. Replica is the default value for this parameter, but it's best to set it to make sure it's not being overridden anywhere else. I'll set up a new runtime parameter with the C flag called max wall senders and set it up with a value of 5. This parameter configures the number of maximum background processes or write-ahead logging senders that can stream the changes from the logs to any connected replica databases. The more replica databases you have, the higher this number should be to keep replication performance working well. The number of senders to configure depends on the CPU and memory usage on your primary database server, since each one will consume some resources on the system. So depending on your infrastructure, you'll need to play around with this number. I'm setting it to 5 as a somewhat conservative number for this demo. The next parameter I'll configure here is max replication slots, and also set it with a value of 5. To explain this setting, I'll need to explain how write-ahead logs are managed on the primary database server. Write-ahead logs are temporary log files that the primary database cleans up after a while so they don't accumulate on the server. That means we need to ensure the replica databases access these logs before they're gone so they can remain synced. A replication slot is a mechanism that PostgreSQL uses to manage the write-ahead logs needed for replicas to read from them. Each replica will consume a replication slot, so the primary database knows that it's consuming these logs, and the primary database will keep the logs until the replica confirms it has them all. This guarantees that the replicas will always have all the data needed to synchronize with the primary database server, even if there's a temporary disconnect between the primary and replica servers. The default for this parameter is 10, but it's generally recommended to set it to about double the number of replicas you expect to have. I only have one replica for this demo, so 5 is more than enough. The last parameter I'll set here also relates to how write-ahead logs are managed. I'll add the wall keep size parameter here and set a value of 64, which means 64 megabytes. This parameter specifies the minimum size of the write-ahead log files that the primary database should keep on the server. As mentioned, the write-ahead logs are usually removed so they don't keep ballooning in size. Setting a minimum size for these logs makes sure that the replicas have enough of a buffer to read from in case something goes wrong. So this serves as somewhat of a backup for replicas. The default value for this setting is 0, meaning that the primary database server won't keep a buffer on standby, which should be okay under normal operation. But setting a value for this parameter helps ensure that any lapse in replication can be dealt with by the replica servers without needing a full resync. So now I have my database all set up for replication. If you're following along, I encourage you to monitor any changes you make to the database server like this to make sure it's not consuming too many resources that can affect its performance. I'll restart the database accessory using Kamal accessory restart and the name of the accessory, which is DB. So the changes to the pg_hba.conf file can take effect, and the database starts up with the replication parameters I set up for it. When the database spins up again, I'll check the logs with Kamal accessory logs db to make sure everything is still working as expected. I can now begin setting up my replica database in Kamal's configuration. I'll start by essentially copying over my existing PostgreSQL accessory, accept the command, and create a new accessory. I'll name this accessory DB replica and change the server host IP and the private network IP I'm using for this server. Since this is a brand new server that I just spun up from scratch, I want to set up Docker in it, which I can easily do with Kamal server bootstrap and use the hosts flag with the server IP address. This command takes care of setting up Docker on that server. Before I boot up the accessory, I'll need to initialize the container to set things up so it knows it's a replica database. Specifically, I'll make sure that the primary database is ready and accepting connections using the replication role I set up. If that's working well, I'll grab a copy of the data from the primary database to use as my starting point for replication before starting up PostgreSQL. I can do all this with an initialization script. The Docker PostgreSQL image is set up to execute any SQL or shell scripts placed in the /docker-entry point-initdb.d directory inside of the container. These scripts run when the PostgreSQL data directory is empty, which normally happens on the first boot only since the Docker container creates a database. So it's important to create the initialization script before spinning up the database server for the first time. I'll create a script in the root of my repository called initreplica.sh to indicate that it's a shell script. I'll start this shell script with the bin bash shebang and set the E argument to exit the script immediately if something fails inside here. Then I'll export an environment variable called pgpassword, which the PostgreSQL client uses as the password when attempting to connect to a database server. I'll need this for the different commands I'll execute in this script so they can connect to the primary database server without user intervention. I'll be connecting to the primary database using the replication role's credentials, which I set in the replication password environment variable, so I can set that here. Now, I want to make sure the primary database is available and accepting the replication role's login credentials from the replica database server. I'll open up an until loop to execute a command until it exits successfully, which I can close with do and done. The command I want to execute here is the pgisReady command, which is a utility provided by PostgreSQL to check the connection status of a database server. This command needs a couple of flags. I'll use the H flag to set the database server I want to connect to. I'll use the private network's IP address of the primary database server here. I'll also specify the P flag to set the port, 5432, which is the default PostgreSQL port. I don't need to add this since it's the default, but I'll make sure it's on the script just to be clear. The next flag is the capital U flag for the user I want to use for testing connectivity to the primary database. I'll use the replication user environment variable since it'll be set up in this container. The last flag I'll set here is D for the database name. The PostgreSDB environment variable that we also set up for this accessory contains the database name we're using for the application. Inside this do loop, I'll echo a message to indicate that we're waiting for the primary database to be ready. So if the PG is ready command fails, we'll see this message in the container logs. I'll also add a sleep for 2 seconds to give the script some time to retry the PG is ready command. If we're able to connect to the primary database, we can proceed with grabbing a database backup to use as our starting point. Another utility provided by PostgreSQL, called pg-base-backup, does just that. This command pulls in the data from a specified database server and places it in a given data directory. This command pulls in the data from a specified database server and places it in a given data directory. It also helps us set up the data for replication, which we'll see shortly. But before grabbing the backup, we need to make sure the directory where we place the data is empty. When starting the Docker PostgreSQL container for the first time, it initializes a database and places its data files in the /var/lib/postgresql/data directory. And it's the directory used by the PostgreSQL server process, so we'll need to set our data in here. The pg-base-backup command, however, requires that the directory where we place the backup data files is empty. So I'll set a remove command here with the rf flags to force remove everything recursively and clear everything inside the /var/lib/postgresql/data directory with the asterisk at the end. With the default data directory cleaned up, I can grab a database backup using pg-base-backup. Like all other PostgreSQL related commands, we'll set a couple of parameters here. We'll start again with the H flag to set up the host, and I'll use my primary database's private network IP address again. I'll also use the capital U flag to specify the replication role's username with the replication user environment variable. A new flag I'll set for this command is the capital D flag. This flag indicates the target data directory we'll use to place the data files for the backup. As I mentioned, the Docker PostgreSQL container looks in the /var/lib/postgresql/data directory, so I'll set that up here. Additionally, I want to log some additional information while this script runs on initialization to make sure that this command is running as expected, which I can do with the V flag. I also want to see the progress of the database backup, so I'll add the capital P flag. This flag is nice to have if your primary database is pretty large, since it could take some time to transfer a copy of the data between servers. Last, but definitely not least, is the most important flag we'll set in the pg-base-backup command. The capital R flag indicates that this backup is for replication purposes, and will create the necessary files needed to run the database server process in read-only replication mode. PostgreSQL determines if a database is a replica by checking the presence of a file called standby.signal. The capital R flag creates this file when pulling in the data backup, along with an additional configuration file containing the connection settings and other details. Without these files set by the capital R flag, any running instance of PostgreSQL in this container will work like a normal database without replication functionality. So it's the key ingredient here for setting up replication. The last thing to do in this script after getting the data from the primary server is to start up the PostgreSQL server. Typically, the Docker container handles this through its entry point, but because we're modifying the data directory in this script, we'll need to explicitly start it here. I can do that by simply running the postgres command. Returning to my Kamal configuration, I'll make sure to copy this file over to the container using the Files setting under the database replica accessory configuration. This setting accepts a list of files to copy from the local repository into the container, separated by a colon. In this case, I want to copy the init replica.sh file from the root of my repo into the /docker-entry point -initdb.d directory and use the same init replica.sh file name. By placing the shell script in this specific directory, it'll run the first time we're booting this accessory. Since we're done with the configuration for the replica, let's start it up to see it in action. In my terminal, I'll boot the database replica using the Kamal accessory boot command with the name of the accessory, which is db-replica. If everything goes well, I should be able to look at the accessory logs for the replica and see that it ran the init replica.sh script that I placed in the container. The script ran through the process of checking that it could connect to the primary database and pull the data from it using PG-based backup. And it also started the PostgreSQL server in read-only replication mode. If I check the logs for the primary database server, I can see that it's generating the write-ahead logs and it's allowing the replica database to access it. So it looks like the servers are working well. Let's double check that the replication functionality is actually working. I'll split my terminal to log into the shell of both the primary and replica database servers using Kamal. The top pane is the primary database and the bottom pane is the replica. I'll use the PSQL command to connect to each database using the U flag and Postgres user, along with the PostgreSDB environment variables to connect to the application database. On the primary database, I'll run a simple SQL query to fetch the first user set up in the users table. So I'll use select everything from users where ID equals 1. I'll switch to the replica database and run the same query to make sure that it's returning the same data. Sure enough, we have the same data on the replica. To make sure that both databases are syncing automatically, let me go back to the primary database and make an update to the user record I just fetched. So I'll run something like update users set name equals something like TeamYap replication demo, where ID equals 1. That'll update the record, and if I retrieve it again, it'll show the updated info. So now I'll switch over to the replica database client and simply run the select query again to see if the changes also appear, and it looks like it did. If I attempt to update the record on the replica database using the same update query as I did on the primary database server, we'll see an error saying that we can't since it's in read-only mode. So all of this means that our replication is now working successfully and the database should remain synchronized. From here, you can use the replica for read-only operations or to switch over in case the primary database server runs into problems. I'll cover these topics in future videos, so make sure to subscribe to this channel to get notified if you're interested in these topics. This video showed how simple it is to spin up a replica of your PostgreSQL database if you're using Kamal to deploy your web application. With a bit of additional setup in your existing configuration, you can have a standby database ready to go at any time without needing to rebuild a new server and restore the data from a database dump, which can be outdated by the time you use it. It's always a good idea to have different ways to recover from data loss in your apps, especially when managing deployments on your own. Using database replication is one way to ensure that you will always have an up-to-date copy of your data in case it's needed, which usually happens when you least expect it. As always, if you found this video helpful, consider subscribing to this channel for more tips on helping developers ship their code confidently, from development to deployment. You can also check my website for more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thank you for watching, and I'll see you in the next video.